In 2025, China isn't following the future, it's building it, one impossible feat at a time. A fusion reactor that burns hotter than the sun, a mission to recover fragments of a ghostly asteroid, solar panels orbiting Earth, beaming power down through space, and the first ever samples from the moon's hidden far side. These aren't isolated achievements, they're signals of a nation charging into a new era, where energy, exploration, and ambition collide. While others talk about what's next, China is putting it on the launch pad, and what they're launching isn't just rockets or science experiments. It's a redefinition of what our species can do. This is more than progress. It's the blueprint for a future far closer than we think. Imagine a machine hotter than the core of the sun, pulsing with stellar energy, designed not to destroy, but to power the future. In January 2025, China's experimental advanced superconducting tokamak, or EAST, broke records by sustaining plasma at 160 million degrees Celsius. That's 5 times hotter than the sun's core, for over 1,066 seconds. It was one of the longest controlled fusion reactions ever achieved. Inside EAST's donut-shaped chamber, a glowing ring of plasma is confined by magnetic fields 100,000 times stronger than Earth's gravity, held steady within walls lined with tungsten. This is the heart of fusion, a process where hydrogen atoms fuse into helium, releasing immense energy, without the long-lived radioactive waste that comes from nuclear fission. But EAST is only one piece of China's fusion puzzle. The HL-3 reactor, located in Sichuan, achieved a major milestone: burning plasma. That's a self-sustaining reaction, where the heat from fusion feeds itself, needing little external input. Just a few years ago, experts thought this was still a decade away. And then there's HH-70, a compact private sector tokamak developed by a Shanghai startup. It uses high-temperature superconducting magnets, cooled to -250 degrees Celsius, which reduce the energy needed to confine plasma by 20%. Its modular, stackable design makes it easier to mass-produce, potentially turning fusion power stations into something as common as solar farms. Together, these 3 approaches form a coordinated strategy. EAST is pushing the limits of endurance. HL-3 is testing what self-sustaining plasma really looks like. HH-70 is aiming to shrink the size and scale up the rollout. In 2025, EAST integrated rare earth alloy magnets, boosting efficiency by 15%, while HL-3's laser diagnostics gave scientists a live map of plasma turbulence, like tracking a storm inside a star. HH-70's scalable architecture opens the door to a future where fusion plants can be deployed rapidly with fewer moving parts. And the fuel? It's everywhere. 1 kilogram of deuterium, easily extracted from seawater, contains as much energy as 10 million liters of gasoline. No carbon, minimal waste, and fuel for millennia. While commercial fusion remains years away, China's advances in 2025 suggest that a star-powered era is no longer theoretical. It's inching closer, reaction by reaction, chamber by chamber. Is this how the next energy superpower is born? What if we could bottle sunlight in space? China's space-based solar power station, or SSPS, is doing just that. Scheduled for testing in 2028, this ambitious project will deploy massive solar arrays, 5 kilometers wide, into geostationary orbit. Suspended 36,000 kilometers above Earth, these panels will capture sunlight 24/7, untouched by clouds, weather, or nightfall, and beam that energy to the ground using focused microwaves. By 2050, SSPS aims to generate 2 gigawatts of clean power, enough to electrify over 1 million homes, with up to 10 times the efficiency of ground-based solar systems. Think of it, a glittering solar mirror orbiting in perfect sync with Earth, constantly soaking in sunlight and transmitting it to massive ground receivers, called rectennas, on the surface. These receivers then convert the microwaves back into electricity, powering cities day and night. Launched via Long March 9 rockets, the components will be robotically assembled in orbit, like piecing together a puzzle in zero gravity. In 2025, China successfully tested a prototype in low Earth orbit. transmitting microwaves over 100 kilometers with 85% efficiency, a major step toward turning this vision into reality. And these rectennas aren't just power stations. They could double as shaded farmland, reducing water evaporation and boosting crop yields in desert regions like Xinjiang. Of course, challenges remain. Launch costs exceed $10 billion. Atmospheric interference causes minor energy losses, and large-scale safety measures will be essential to keep microwave beams secure and focused. But China's simulations, powered by AI, along with lightweight carbon fiber panel designs, are helping accelerate deployment. The concept isn't new, but the execution is. If China pulls it off, cities could one day run on starlight, flicking on at night with energy beamed directly from orbit. No smoke, no fuel, just clean, continuous power from space. Could SSPS redefine how nations compete, not for oil, but for orbit? Imagine a spacecraft dancing with a tiny asteroid that may have once belonged to the Moon, before slingshotting across the solar system to chase a comet trailing 6 glowing tails. Launched in May 2025, China's Tianwen-2 is one of the boldest missions in deep space history. Its first destination, Kamoa-Olewa, a 40-meter-wide asteroid locked in a synchronized orbit with Earth. Some scientists believe it may be a lunar fragment, blasted into space by an ancient impact over 1 million years ago. By July 2026, Tianwen-2's lander, equipped with a robotic arm and a diamond-tipped drill, will collect around 200 grams of regolith, the dusty surface material. These samples will return to Earth in 2027, blazing through the atmosphere at Mach 35, glowing like a man-made meteor. But that's only half the story. After releasing its cargo, Tianwen-2 won't head home. It'll keep going. Using a gravity assist, the spacecraft will redirect itself toward Comet 311P/Pan stars, a bizarre object that behaves like both an asteroid and a comet. It sports not one but 6 dust tails and erupts in mysterious bursts of material. Tianwen-2's extended mission will reach it by 2034. In 2025, its onboard spectrometer already scanned Kamoa-Olewa from afar, detecting iron-rich silicates, hinting at its moon-like makeup. Once back on Earth, scientists will examine the samples under electron microscopes, looking for minerals like anorthosite, the same material found in the Moon's highlands. Confirming its origin could rewrite our understanding of lunar impacts. And the comet? It may hold organic molecules, ammonia and water ice, the same ingredients that seeded early Earth. By sampling both bodies, this single mission could help answer 2 of humanity's biggest questions. Where did the Moon come from, and how did life begin? But there's more. Missions like Tianwen-2 also pave the way for asteroid mining, unlocking access to platinum group metals and rare Earth elements. Or they could help guide future missions to Phobos and Deimos, Mars's mysterious moons. From a rogue lunar fragment to a cosmic snowball, Tianwen-2's path spans over 500 million kilometers, navigated by AI and solar sails. It's not just a scientific mission, it's a statement. China's saying, we don't just visit space, we explore it. Let's journey to a place no human has ever seen with their own eyes, the Moon's hidden hemisphere. In 2024, China's Chang'e 6 mission accomplished something no nation had done before. It landed in the South Pole Aitken Basin, the largest and deepest impact crater in the solar system, and returned nearly 2 kilograms of lunar material from the Moon's far side. By 2025, those samples were revealing astonishing secrets. Scientists uncovered basaltic rocks from eruptions dating back 3.2 billion years, and magnetic signatures pointing to a lunar dynamo. Evidence the Moon once had a molten core generating a magnetic field, much like Earth's. That field may have shielded the Moon from solar radiation before mysteriously vanishing over 3.5 billion years ago. Chang'e 6's rover, Jinshan, scanned over 12 kilometers of rugged terrain using infrared spectrometers. It mapped minerals like olivine, pyroxene and ilmenite, painting a picture of a volatile and volcanic early moon, one very different from the near-side's smooth basalt plains. But the mission found more than rocks. It also confirmed the presence of helium-3, a rare isotope deposited by solar wind, scarce on Earth, but potentially abundant on the Moon. Scientists estimate that 1.1 million metric tons lie beneath the lunar surface. Just 25 tons could power the United States for a year using advanced fusion reactors, with far less radioactive waste than traditional methods. China's Chang'e 5 mission had previously detected helium-3 in lower concentrations, but the far side, more exposed to solar wind, may hold higher yields. Still, extracting it isn't simple. 1 ton of helium-3 requires mining 100 million tons of regolith, demanding massive infrastructure and gigawatts of energy. But China is playing the long game. Using advanced mass spectrometry at the Beijing Geology Institute, researchers are now cataloguing the far side's composition. And in another show of leadership, China shared some of its lunar samples with NASA-funded scientists, defying political tensions to build scientific bridges. Chang'e 6 also tested in-situ resource utilization, extracting water, oxygen, and even methane from lunar soil. These tests are crucial for China's planned International Lunar Research Station with Russia, scheduled to begin construction by 2035. From unlocking ancient magnetism to testing fuel production in space, the Moon's far side is no longer a mystery. It's becoming the proving ground for human settlement beyond Earth. Imagine capturing the universe's first whispers, echoes from a time before the first stars were born. That's the goal of China's planned Lunar Radio Telescope, a bold mission set for the early 2030s. Unlike Earth-based observatories, this one would sit on the far side of the Moon, permanently shielded from the radio noise of our planet. It's one of the quietest places in the solar system, an ideal place to listen to the cosmos. The telescope's mission? To detect hydrogen emissions from the cosmic dark ages, a mysterious era more than 13.8 billion years ago, when the universe was just a cold soup of neutral hydrogen. Long before galaxies, before stars, before light as we know it, these low-frequency radio waves were the only signal. To catch them, China plans to deploy an array of 100 or more antennas across a lunar crater. Rovers, likely adapted from the Chang'e mission designs, would carefully lay out each antenna on the Moon's rocky surface, operating autonomously in sub-zero temperatures and harsh radiation. Once active, this telescope could peer further back in time than anything humanity has ever built. It could reveal how the first stars ignited, how galaxies began clustering, and how dark energy shaped the early expansion of the universe. More than a telescope, it would be a cosmic time machine. And it wouldn't stand alone. The project ties directly into the upcoming International Lunar Research Station, where China and Russia plan to build out permanent infrastructure on the Moon. If successful, this observatory won't just change astronomy. It could help answer one of the oldest questions we've ever asked. Where did it all begin? What invisible threads hold the universe together? In 2025, China's 500-meter aperture spherical telescope, better known as FAST, uncovered something extraordinary. A network of cosmic filaments hidden inside a high-velocity cloud, racing through interstellar space at over 300 kilometers per second. These aren't stars, they're vast strands of hydrogen and helium gas, stretching across hundreds of light years, forming the backbone of the universe. Cosmic filaments channel matter into galaxies and feed the birth of stars, like rivers nourishing an invisible forest in space. FAST, the world's largest single-dish radio telescope, sits in a natural sinkhole in Guizhou province. Its 500-meter dish, larger than 30 football fields, acts like a massive ear, tuned to the faintest signals from the edge of space and time. In 2025, FAST used quantum-enhanced processing to map subtle shifts in filament density, offering new clues about dark matter, the invisible mass that shapes galaxies but has never been directly observed. At the same time, FAST continues to monitor pulsars and black hole binaries, helping track gravitational waves that ripple through space from ancient collisions. Some scientists believe these filaments may even carry primordial magnetic fields, leftovers from the Big Bang itself. Others speculate they could guide the search for extraterrestrial intelligence, focusing our attention on cosmic highways, where life might more easily spread. For now, the universe's skeleton is taking shape, and FAST is helping us see it for the first time. As China listens for the whispers of creation, it's also laying the groundwork for what comes next. Rockets that fly to space and land themselves back on Earth. In 2025, China's private space sector made a bold leap with the rise of reusable launch vehicles, echoing the breakthroughs of SpaceX, but adding its own innovations to the mix. Two companies led the charge: Astronomy and Cosmolab. Cosmoleap's flagship rocket, Reusable, is powered by methane-oxygen engines that deliver over 200 tons of thrust, efficient, clean-burning, and designed for multiple flights. But what sets it apart is its tower-based recovery system. Like SpaceX's Chopsticks, it doesn't land on a pad. It's caught mid-air by an AI-guided tower, using precision LiDAR and sensor arrays to snatch rocket out of the sky like a mechanical claw. In 2025, Cosmolab conducted 3 successful test flights in Hainan, recovering its booster stages with 99% accuracy and reducing launch costs by over 30%. Not to be outdone, Astronomy launched its own prototype using cryogenic methane, a propellant that could be produced on Mars, hinting at interplanetary ambitions. Its test flight reached 50 kilometers in Gansu province before returning safely, paving the way for orbital trials. This surge in private innovation marks a new chapter in China's space ambitions. For decades, the country's space program was entirely state-run. Now it's being fueled by university talent, commercial capital, and startup agility. Reusable rockets mean faster launch turnarounds, lower costs, and greater access to orbit for everything from climate monitoring satellites to space tourism platforms. Imagine boarding a suborbital flight in Shanghai, watching the curvature of Earth before gently descending to a precision landing, or mining Martian ice and fueling rockets in orbit, all made possible by tech born from test flights happening now. In 2025, China's rockets didn't just launch, they came back, ready to fly again. And the space race? It just became a whole lot more competitive. From forging stars in reactors to catching rockets in mid-air, from mining ancient lunar basins to mapping the universe's hidden scaffolding, China's 2025 breakthroughs are more than headlines. They're a vision. Tianwen-2's deep space chase, Chang'e 6's secrets from the moon's far side, a telescope listening to the whispers of creation, solar panels orbiting above the clouds, each one part of a larger arc, a trajectory pulling us closer to a multi-planetary future. These aren't isolated feats, they're stepping stones toward lunar outposts, Martian landfalls, and a civilization powered by fusion and sunlight, not coal and compromise. From helium-3 to hyperspectral lenses, from quantum data to reusable rockets, China is showing the world what happens when ambition meets execution. So, what lit the fuse in your imagination? Was it the artificial sun blazing in a tokamak chamber? The spy tech lenses that turn darkness into sight? Or the spacecraft surfing millions of kilometers to chase a ghostly comet? Drop your thoughts in the comments. Let's talk about what's coming and who's leading the charge. If this journey through the cutting edge sparked your curiosity, hit like, subscribe, and ring the bell. We're just getting started. Thanks for watching. And as always, keep chasing the stars.